Okay, so we have one more page of this practice test, and that's it. So now we're doing problem 7, which says, find a direct algebraic relationship between these two equations. All right, so what do we do? Who remembers? Anybody? How do we find a direct algebraic relationship?
You're going to get t by itself.
Get t by itself. And you can do it in either equation, but it might be easier to do it in the top one. So t will equal x minus 4.
And then plug that value in for t in the
that goes in here. So y equals 2 parentheses x minus 4 minus 3. So 2x minus 8 minus 3, or 2x minus 11. And there is the direct algebraic relationship between x and y. Remember, we want one equation, no t's. Number 7. We want to know if these guys are inverses. Now, this goes back to something that we talked about with inverses. Remember, with inverses, the x and y switch, right? So we looked at problems where if we stuck a 2 in to the function and it came out as a 10, what happened when we put the 10 into the inverse? It came out as 2. So if these two are inverses, I should be able to pick a random number like 5, and I should be able to put 5 into f. And what would I get if I put 5 into f?
6.
I would get 6. Now I'm going to take that 6 and put it into G, and what better happen? I better get 5. Well, do I? If I put 6 in here, I think I get 7, don't I?
Yeah.
So they aren't inverses. And you're going to explain that by saying exactly what happened. When I put, I picked 5. You don't have to pick 5. You can pick whatever number you want. But I picked a number and plugged it in. Then I took that answer and put it in the other function, and I didn't get my original number back. I had to get 5 here. If I got 5 here, they would be inverses. Okay? So we plugged in 12 and got 20. Then we plugged in 20 and got 14. No, they're not inverses. Okay?
So, in order to get inverse, the second equation, the answer has to be the value that you plugged into the first one?
Yep.
Okay.
Yep. Now you're actually finding an inverse. So we have 2 of these problems, one of which we had on a quiz. I have 2 of them. But now you're actually finding the inverse. So who remembers the steps to this? This is an easy one. So we're going to switch the variables. So we're thinking of this as y, right? So we switch the variables. And it looks like this when we switch the variables. And now multiply by 4, so 4x equals negative 2y plus 9. Now what? So we've got to subtract the 9. And then divide by negative 2. So then the answer blank will say f inverse, that is our function, or excuse me, our inverse notation right there, f inverse is 4x minus 9 over negative 2. So we switch the variables and solve 4y.
Don't forget to change the sign, the other one. Like both sides don't change, but the other one does.
Now, this one is a little bit harder. We're going to do it the exact same way, but there's going to be more arithmetic involved. So think of that as y, and then switch your variables. Okay, so now we're here.
2x minus 2.
What do we do now?
Times it by 2y.
Move this over to here, and then remember that when you move that over, this becomes a distributive situation. So 2xy plus 4x. That is a distributive. Okay? And then what?
2 divided x.
Got to put all the y's on the same side, because in the end you're only allowed to have one y, and so we're going to have them on the same side. So I'll subtract it over, and I got to move that 4x over, because the only way to get one y is going to be to factor it out.
Yep.
And then we'll divide. Remember, dividing by the parentheses. And then putting it back in our function notation. And there we go. We had a quiz over that. That problem has a lot of steps. This one does not. This one is super simple. Your job is to find the ordered pair, so your answer is going to look like x comma y. And how are we going to find x comma y?
Plug it in each equation.
We're going to plug -1 in. So plugging -1 in here gives me 1. And plugging -1 in here gives me 4/3. That's it for that one. That's all there is to it. Easy.
Now you dress very fast.
Can you wait? So, I mean, we only have 17 more minutes. If it's an emergency, go ahead. But, all right, here we go. Number 10 is a multi-part problem. So we have to figure out what's going on in number 10. There's a lot going on. Okay. So, I'm going to look at the original picture. And I would suggest that you label these points. Of course, you don't have to, but it might help to label them. So I've got my original shape. There it is. And I've labeled all of those points. And the reason that I labeled them is because now I'm going to sketch the inverse. And you remember how we do that? It's real simple. We just flip the x's and y's. So go point by point, only instead of having -4, 0, we'll have 0, -4. And then we'll have -2, -3, -1, -2, -3, -1 won't change. 0, 0 won't change. 1, 2, and 0, 3. And then when you connect those, that will be your inverse. So it's very, very simple. You just have to take all the points on the original picture, flip them, and then connect them. Pretty easy. That's question A. Now, keep in mind, this is f of x. This is f inverse, right? Okay, so now we're going to answer some questions. Is f of x a function? Is this a function?
Yep.
Yes, that's a function. Why or why not? It passes the vertical line test. Okay? Now it says, is this a function? No. Why or why not? It doesn't pass the vertical line test, right? Pretty simple. Now, is this then considered 1-to-1? No, because to be 1-to-1, they both have to be inverses. They both have to be, or inverses, they both have to be functions. They both have to be functions. If you're 1-to-1, then you are a function and your inverse is a function. So the answer is no, they're not 1-to-1 because they aren't both functions. You could also go back to the horizontal line test and say this guy does not pass the horizontal line test. And to be 1-to-1, you have to pass both vertical and horizontal, and he does not.
Will you ask like the type of equations that pass that are 1-to-1 and
What?
will you like
Maybe.
maybe?
So just draw something that passes both. The
No, but like
horizontal,
some of them like pass the vertical line test and some of them pass.
there are some that pass
So
both.
I can ask that.
I might. I mean, you talked about it. Okay, number 11. Number 11. This is a little bit tricky. What's going on here? You have to figure out how we got from picture 1 to picture 2. Now, the hard part here is the axes don't show up very well. So I'm not plotting points and all that, but that's where the axis is in that first picture, and then in picture 2, this is where the axis is. Okay? So I know it's kind of I did a real good job graphing it, but you need to talk about, or you need to write an equation for this. So this is f of x. So now you need to write an equation for this that is like 2f of x plus 3, or that kind of stuff. You have to put numbers into it.
Oh, I got you.
So in order to determine what kind of numbers you're going to put in, you got to figure out what changed. So what changed going from here to here?
It flipped on the y-axis.
It flipped upside down, right?
Flips
And it also flipped
on the x-axis.
sideways. So it's an upside down and it's sideways. Did anything else happen? Did it get moved at all? You gotta pay attention. I didn't put mine on a grid, but on the grid, I believe the semicircle and the triangles are the same size. They haven't changed in size, right? And nothing has been moved left or right. It is still pivoting right here on the origin, right?
Right.
So I think those are the only 2 changes that we have.
Why is the triangle?
Yeah, like a bigger, smaller.
Well, I'm just doing a rough sketch to show you, use what's on the paper. I just wanted you to see where the axes were because it's hard to tell.
On the paper, it's
Oh, that's the other one. That's the other one. That's the other one.
It got flipped upside down and sideways, so the triangle split. Look at this one? The middle one goes upside down.
Okay, so what would that equation look like?
Y equals negative
Negative
f.
f,
Negative x.
negative x. Because to accomplish flips of any kind, you have to put negatives in, right? And in this case, since we're doing both flips, we had to put in both negatives. All right, practice test 2. Here we go. That's it. That's the whole test. We just took the whole test and all the talking and all the messing around. We just took the whole thing. So here we go. Now we're on practice test 2. Now we have this general shape. All right, so we have that guy, and then we have this. So again, I'm going to start with my original dimensions. This guy's 2 high and 4 wide, and this guy's 1 high and 4 wide. The very first problem has 2 things. It has a negative 2, well, it has a negative and a 2. All right, so we're looking at the first problem, A. What does this negative in this spot do?
Upside down.
Sideways flip.
That's a sideways. This is a sideways. So what that means is the circle, the semicircle, is going to be on this side. And the trapezoid is going to be on this side. Now, all I've done so far is take care of this of the flip, but I flipped it sideways. That's the negative part. Okay? Now, what does the 2 do? Divides the width. So that means this semicircle, which was 4 across, is now going to be, I'm dividing by 2. What's 4 divided by 2?
2.
That would be 2. So it is now going to be 2 across. So the red, I'm going to go ahead and take the black out because it's kind of confusing. There is my semicircle. It still goes down 1, but it's only 2 wide instead of being 4 wide. And then my trapezoid was also 4 wide, so now it is going to be just 2 wide. Again, I'm going to take the black out, that confuses. There it is. So I flipped it sideways, and I made it half as wide. All right, let's see what happens here. All right, what does the absolute value do? That's bottoms up. So what that means is, in my original picture, the trapezoid is staying put, and the circle is coming up. So there's the bottoms up part. That's the first part of the picture. Now what do we do?
Move it up.
Now it goes up 1.
Yes.
So I take every one of those points I just got done plotting, and I move them up 1. So my trapezoid's up here, and my circle's up there. Gotta use the original picture every time. happens here? There's only one thing going on. We got a 1/2 here. What does this guy do? Divides the width. So that, nothing moves, everything stays put. So how wide is my semicircle? Well, it's 4 in the original, so now it's going to be 8. So here is now my semicircle. 8 across. Because 4 divided by 1/2 is 4 times 2. And then the trapezoid, same thing. He's too tall, that hasn't changed. But now he is 8 across. So there's the picture, twice as wide as the original. Nothing else changed. It's just twice as wide. All right, gotta get these next 2 done. Here we go. What's happening in this one?
Height
This multiplies the height,
is right 3.
and this is gonna go right 3. So you can do that in 1 step or 2, whatever's easiest for you.
Oh, that one.
Okay, now keep in mind, we're going right 3. So this point right here, the beginning of the circle, is actually going to be here now. So my circle, I'm going to draw my circle here. It's still down, there's no negatives, but it's twice as big. So now my circle is going to come down 2. Would you agree with that? So there's my circle, down 2, because it's doubled. And then my trapezoid is it's going to be from here to here, but it's actually now going to be 4 tall. So there it is. I did both things at once. You do not have to. You can do them one at a time. Moved it 3 to the right and multiplied its height by 2. So the trapezoid's now 4 and the circle's now 1 or 2. And then one more. I'm going to stop on this test for the day. Alright, so what happens here? A lot, that's right. There are 3 things happening in this picture, right? What are the 3 things? What's this? Upside down. What's this? Multiply the height. What's this? What is it? Near or right? Alright, so I'm going to start with that. Whatever's on the right side of the picture, which is the circle, gets drawn. So here's my circle. Then I draw the same thing over here. That's it. So that takes care of this right here. Now, what does this do?
Upside down.
Flips it up, so it's going to have this shape now, right? And makes it
The height.
twice as tall. So now the circles are going to be up here, like that. And that's it. That's all there is to it. It turned it up right side or upside down and made it twice as tall.